All right, so we're now moving on to the next section of this unit, and that's going to be section or unit 3C, and we're going to be solving and graphing what are called compound inequalities. All right, so we're going to be learning now what are compound inequalities. So that's our learning objective by the end of this video, is you'll have to know what a compound inequality is, and you'll have to know how to solve them. And what they are is they are and or statements. So you need to be able to understand what we mean when we say the word and what we mean when we say the word or. All right, so we're going to first talk about the difference between those two words and what it means when we're solving these questions. Hopefully you would already be able to know how to do that part of it. And then we're going to extend that into actually solving inequalities and see how that looks. All right, so compound inequality, or a compound inequality, is an inequality formed by joining two inequalities. So we're now looking at two separate inequalities, and they're combined with the word and or the word or. And we need to solve both of these inequalities, and based on if it's an and statement or or statement, it then dictates what our final answer would be or what we need to look for. All right, so before we actually get into it with actually solving any compound inequalities mathematically, let's just talk about the difference between an and or an or statement with just regular statements that we might see around the world. So the one thing I came up with is, let's say next year AIS is changing your uniform. So instead of the current shirts that you wear, you can now wear any shirt, but it must be blue and white. So which of these following shirts can you actually wear? So can you wear shirt A? Can you wear shirt B? Or can you wear shirt C? All right, so this answer would be that only shirt C would satisfy this uniform change because it says it needs to be both blue and white. So even though this shirt here is blue, there's no white to it. So you can't wear it because of the word and. The word and means it needs to be both of them. So it needs to satisfy both of our constraints, that it needs to be blue and it also needs to be white. We can't do B because B here does have white, but it has no blue. So once again, because the word and means it needs to satisfy both of them at the same time, the only one that you could wear to school and be in the new school uniform is letter C, because it is both blue and white. So when we say the word and, it needs to satisfy both of our inequalities at the same time, right? It needs to satisfy both of them. All right, so now let's talk about what it means to be an or statement. And so now we change this. It says, instead of our AIS policy changing, okay, well now we need to be both blue and white, it says, hey, it could be blue or white. So as long as if it's blue or it's white, you can wear this shirt. So now, once again, which one of these shirts can you actually wear? And in this case, you can wear all of them. All of them satisfy this constraint because the word or means it needs to satisfy one or the other. So as long as if it satisfies one of them, then it satisfies this constraint. So it needs to be blue or white. Well, this shirt is blue, so it works. This shirt is white, so it works. This one is both blue and white, so it satisfies both of them. But we only need to satisfy one at the same time, so all three of these work. All right, so that's the big thing. When we're satisfying, when we're doing our and statement, let me scroll down a little bit. When we're doing our and, it needs to satisfy both. And when we're doing our or, it just needs to satisfy at least one. So I'm going to change that to at least one. All right, so now we're going to take this and use this and apply this to mathematical inequalities. All right, actually, before we get into solving any problems, I want to show you how they can actually appear in questions. So if we want to go over what the and statements will look like, a lot of the times you won't see the word and. It'll be written like this, where your variable is written in between, it's sandwiched in between two separate inequalities. And this implies n because this needs to be greater than -3 and at the same time needs to be less than or equal to 9. So this actually generates two separate equations or two separate inequalities where it will separate this inequality where -2x plus 1 is greater than -3. And that's this first one. And then it will create the second inequality of -2x plus 1 is also less than or equal to 9. So it creates this second inequality here. All right, so sometimes they might write it out for you with the word n, but that's really rare that they actually write the word n. Usually it's going to be given to you in this form here where your inequality is sandwiched, or I'm sorry, your variable is sandwiched in between two inequalities, and then you have to separate that and create the two inequalities. And when it's written in between like that, it means and. For the or statement, though, it has to say the word or. So if you don't see the word or, then it is not an or statement and it is an and statement. And then once again, we're comparing these two different inequalities, and we'll go through actually what we need to do. But when it's an or statement, it needs to satisfy one or the other. So at least one, it just needs to satisfy. Where this one, the end, it needs to satisfy both this and this at the same time, which is why we can write it in between our two inequalities like that. All right, so let's go ahead and answer a couple questions. All right, so the first thing you have to do is you have to be able to identify, is this an and or statement? And since I don't see the word or, and I see it's sandwiched in between, my variable is sandwiched in between my two inequalities like this, I know it is an and statement. So this means it needs to satisfy both at the same time, right? That's key, that's what you have to know. And what you do is now we're going to separate these and actually create the two different inequalities that we see. So we're going to do that x minus 5 is greater than 4, and then we're going to also do the inequality of x minus 5 is less than or equal to 7. And then we solve each of these individually. So to solve for this, I need to add 5 to both sides. So x is greater than 9. And then to solve this one, I need to add 5 to both sides. And that means x is less than or equal to 12. Now remember, it is an and statement. So we need to satisfy both of these at the same time. So what we need to do now is we need to actually graph these. So I'm going to go ahead and make my graph here. So let's just say 8, 9, 10, 11, and 12. So I just need to make sure that my graph covers both of these numbers. All right, so then I'm going to graph them individually. So x is greater than 9. So I know it's an open circle. And then since it's greater than, it's going to go in this direction. Actually, let me just graph this a little bit better, a little bit higher. So x is greater than 9, open circle, it's going to go in this direction. And then I'm going to graph the blue one. X is less than or equal to 12. So since it's less than or equal to, that's a closed circle. And then it's going to go less than, so it's going to go in this direction. Right? So now we need to satisfy both of these at the same time. So that means if any answer on the blue that goes beyond my red graph doesn't work, because if I pick 8, 8 will only satisfy the blue one. 8 minus 5, is this less than or equal to 7? 3 is less than or equal to 7, so it works. But if I plug it in here, 8 minus 5, is this greater than 4? Well, no, 8 minus 5 is 3, and 3 is not greater than 4, so it doesn't work. So you see, any of the answer beyond that red can't work. And the same thing on the other side. Any answer beyond my blue doesn't work either. If I were to pick 13, well, if I plug 13 in, 13 minus 5, is this less than or equal to 7? No, 13 minus 5 is 8, and 8 is not less than or equal to 7. So we know it can't go beyond that. So our final answer then is where our two graphs overlap. So that means my final answer will be an open circle at 9 because it can't be included because it won't satisfy that red inequality, and a closed circle at 12, and then we can just draw those two circles, those 2 points meeting. So our final answer is where they overlap, right? It's where they both share because it has to satisfy both of them at the exact same time. And anything beyond this region, although it satisfies the red, it does not satisfy the blue. And anything beyond this region, although it satisfies the blue, does not satisfy the red. So we have to pick the parts where they overlap. So your final answer is just this purple graph. Now you will submit it to me with all of your work. So you will submit it to me with your two graphs actually overlapping. So really you'll graph like 3 different graphs here. And we'll talk about exactly what I want yours to look like. All right, but for an and statement, they need to overlap. All right, now let's go ahead and do an or statement. All right, so now let's do our second problem. This is the last problem we're going to go through in this video just for interest of time. All right, so it says or. So negative 2x minus 7 is less than 5, or negative 5x plus 6 is greater than or equal to 41. These are actually really simple. All we do is we just solve both of them individually, graph both of them, and then that's our answer. All right, so let's go ahead and solve. Negative 2x minus 7 is less than 5, so I'll add the 7. So negative 2x is less than 12. We divide by negative 2. Whoa, now that we're divided by negative, I need to flip my inequality. So x is greater than negative 6. I'm just going to go ahead and graph that. So let's go ahead and say negative 8, negative 7, negative 6, negative 5, and negative 4. So now we're going to go ahead and solve the other inequality. All right, so now we just do negative 5x plus 6 is greater than or equal to 41. We'll subtract our 6, so negative 5x is greater than or equal to 35. Now we divide each one by negative 5. X is then, so we flip our inequality, is now less than or equal to negative 7. Right, and now we just graph these individually. So we graph our red one. It's going to be an open circle at negative 6. It's greater than, so we're going in that direction. Our blue graph is less than or equal to negative 7, so that means it's colored in, and it's going in this way. This is our answer. There's some special cases that we'll talk about in the future, but when we're doing or statements, we just have to plot them and graph because it only needs to satisfy one or the other. So the only answers that don't actually work for this are any number that's in between negative 7 and negative 6, including negative 6. So every other answer will work. If I pick negative 5, yeah, it won't satisfy this inequality, because if we plug in negative 5, we will then get negative 5 times negative 5 plus 6. Is this greater than or equal to 41? So 25 plus 6, so 31 is not greater than or equal to 41. But since it's an or statement, it doesn't have to satisfy both at the same time. It only needs to satisfy one of them. And negative 2 times negative 5 minus 7, is this less than 5? Well, this is 10 minus 7, and 3 is less than 5. So you see it satisfies this inequality, so that means it works. All right, so when we're graphing or statements, we simply just graph them, and that is our answer. So it's less thinking that we need to do for the end statements. However, just like there's special cases that give us infinitely many or no solutions, there are special cases for compound inequalities that do the same, and we'll talk about those in class. All right, so there's one more thing that we're going to talk about in this video, but this is our last example that we're doing. Hey, I just thought that this would be a good way to end the video because it talks about both the and or the or statement. So remember, solutions of a compound inequality with n consists of numbers that are solutions for both of the inequalities. So if we have these two inequalities of x is greater than or equal to 2 and x is less than 5, well, we're looking for ones that satisfy both. All right, so remember, it's where they overlap. And just make sure you're keeping your endpoints the same. So it's an open circle, closed circle, so they need to be the same when we're filling them out. And then when it's an or statement, or just needs to satisfy at least one of the inequalities. So if we say that y is less than or equal to negative 2, or y is greater than 1, then it just has to satisfy one or the other. So that is our answer, where we just graph them together on the same number line. All right, that is it for this video.